Nuts Matter Theaters, as many of you are, and I'm a director for the school. So I wanted to spend a few minutes telling you about the school and some of the logistics, and then introduce the scientific organizers who will tell you a little bit more about the program. So again, it's a great pleasure for me to welcome you all to Boulder and to our summer school. This is the 14th school. The inaugural school was in 2000 on superconductivity. The idea for the school was conceived by Steve Gervin and then founded in 2000 by Matthew Fisher, Andy Millis, and myself. We wrote an NSF proposal to try to put this together. We were all envious of the Europeans and other parts of the world running all these amazing schools. And Steve Gervin really was the one who emphasized that a school, given the amount of activity in material science and condensed matter physics, a school like that in the United States was long overdue. So here it is. We're now in our 14th year, and we've had really amazing success with these schools. Every year we invite 65 students, best and brightest students from all over the world, to come and join us here and be lectured to by 25 or so faculty from all over the world, experts in the school. And schools typically alternate between soft matter and hard matter. It's not a hard rule, but on average, that's what we do. So again, so the school was founded in 2000. It's supported by the NSF to a pretty large, to a tune of about $250,000. So that's what it takes to put a big operation like this, to house you all here for 4 weeks and to pay for all the flights out here for the lectures and for the students that are coming from U.S. universities. We have a board, advisory board of 20 very distinguished scientists. Anyway, so the school, of course, is like as I said, have been very successful on a broad range of topics, ranging from superconductivity, magnetism, cold atoms on one hand, but then biology, biological physics, polymer physics, glasses on the other hand, so soft and hard matter balance. And you know, there's a lot that goes on behind the scenes, and I will talk a little bit about that in making this happen. But of course, big part of it, the success of the school, comes from the organizers, scientific organizers. So I see only one of them here, Victor Gurari in the back. So you guys will get to know Victor, if you don't know him already, pretty well over the next 4 weeks. There's also Gil Raphael from Caltech. Victor's local from CU, if you don't know. Raphael's coming from Caltech. There's Julia Maya from Grenoble, and she's coming midweek. And Yamir Yacobi is from Harvard, but he's not going to be here, unfortunately. So they worked really hard to put this amazing program for you, and Victor will say a few words about it after I'm done boring you with the sort of more administrative, less interesting things, but maybe one time it's good to say. Victor will talk about give you an overview of the scientific program. Let's see. Okay, so yeah, so my point was that scientific organizers and a lot of administrative things behind the scene is what makes this school work. But really, setting that aside, really what makes it work is students. Okay? The reason the school is so successful is because the students come all eager to learn, and they're into the school. They ask questions, they interrupt lectures, they really want to, they meet their classmates, they organize poster sessions, seminars. They go on hikes on weekends. There's a lot to do, both scientifically and socially, and that's what really, what really makes it work is students who are, proactive and really make this a tight-knit class that's, that will then take you to the future, into your academic future, and here you will meet future collaborators and colleagues as you go on to your successful careers. And in fact, one measure of how successful the school has been, we have had. Already even a couple years ago, but particularly this year as well, students from the first school and first and second and third school come back and not only lecture, but actually organize a school. So for example, Gil Raphael was one of the best and brightest in the first school on superconductivity. One of the students asked lots of questions, was very visible, and now he's a big shot professor at Caltech. He's now coming back. He's come back already lectured at the school, at previous schools, but now he's actually organizing the school. So yeah, so your job is, not to cruise the web, not to check your Facebooks or posts, but to sit there and challenge the lecturers, really get involved in the lectures, and try to initiate some activities. Soccer games, on one hand socially, but on the other hand, you know, we have anything you want available for you. We have extra seminar rooms, so if somebody wants to take charge of organizing seminars, we can make that happen. The schedule is pretty packed, but there's definitely, you can run, in the past we have run, or students have taken initiative to run student seminars in the evenings, for example, okay? So please, I really challenge you to do that. One formal aspect that somebody has to take a charge of is t-shirts. And you got that email from Daphne. I hope everybody's received that email and took a note of it. So as you can see here, there's some t-shirts from past schools. So every year, we have students take charge of organizing, designing proposing a design, and then sometime in the second week, end of second week, we all decide on what the best design is, and we will then put it on t-shirts, and we'll pay for everything, and everybody will have a t-shirt with a design to remember the school by. So what I want to ask is some volunteers, and you don't have to raise your hand now, but please approach myself or one of the other organizers if you want to participate and basically start brainstorming, get together with students, start brainstorming about designs of the t-shirt. You do not want to be the only class known for not having a t-shirt to represent the summer school. You want to have the best t-shirt. Look at that quantum coherence t-shirt of the Cheshire hat in the end there. So there's quite a few very nice designs, and they all reflect the theme of the school and some kind of an interface between the theme of the school on one hand, on the other hand, some social aspects of the locale of Boulder, the mountains and things like that. Okay, so the other, something that I alluded to, administrative aspects of the school, a lot of it was thanks to the hard work of Dakota Nanton in the back. He's going to be doing, he's an important man because he's also, in addition to doing all the administration for the school, he is going to be doing a reimbursement for those who are coming from U.S. universities and getting reimbursed. So, so he's an important guy, and he will attend to many of your other administrative needs for the next 4 weeks. The other two are my students. One of them is not here, but Xiaoying is here, so they're Xiaoying. So anything, you know, any little details you can put on him. He's really friendly and tireless guy, so he will help you out. If you have any questions about campus, anything local, his job is to video record the lectures and do the webcast, but he'll also answer your questions and help you out with any way he can. Now, again, for those of you who are getting reimbursed, including the lectures, of course, the way we're doing the reimbursements, there's a woman in the main physics office, Marilyn. So you simply go down to the main physics office on the ground floor and ask for Marilyn. She's in the front office, and she'll ask some information from you to start a file for you for reimbursement. So again, if you're coming from U.S. University, you will be reimbursed for up to, I think, $500 for your travel. Is that what it is, Dakota?
It's up to $500, and it helps if you bring all your receipts with you when you go down.
Yeah. You can email it, you can mail it later, but then it just makes things very complicated. So I urge all of you, if you're getting reimbursed, to do it now if you want to get reimbursed in a timely fashion. You'll have library privileges here. There's a rec center, although it's under construction, under renovation, I should say. So it's a little bit complicated to navigate, just like around here. We seem to have be really heavy in construction. Still, there's a rec center. You can pay at the door. All you have to do is show your badge, so then you can get in there. There's a wireless internet that you have. We have as a school, we have an account that I can write down. In a second, I'll write down the username and password, and then I'll quickly erase it. For that, you can actually log in and use the computer lab across the hall. But I think the guest account is not password protected. I haven't tried because it just works directly. So if you're just trying to cruise the web and things, not during the lecture, then that's fine. But if you want something more heavy duty, and you really want to log into to a machine, let's say across the hall, then I'll give you a username and a password that's used as a group, that you can use as a group. In fact, let me write it down now. So let's see if I can remember it. So it's CONF for conference, Condensed Matter Summer School. That's the username. And let's see, it's Condensed Matter Summer School, comma, July 13. Okay? They make me use, you have to use always every type of a character in there.
So the J is capital?
No, it's not. Nothing's capital. That's why I erased it. Okay. I'm told by conference sources to tell you that there's no, University of Colorado forbids having alcohol in public areas. So if you want to drink yourself to your heart's content, do it in your room, in your dorm room. That's fine. If you're struggling to understand some lecture and you're having a difficult time, you can do it in there. But we'll get in trouble if we're, unlike Europe, you can't walk around the streets having an open container. They'll give us a lot of trouble. Let's see. There are no meals on weekends. You can go out and, in part, that's done so you can go out and explore fine cuisine that Boulder offers you. We have soccer balls. We have basketballs and all kinds of other equipment that if somebody wants to take charge of for duration of the school and run afternoon soccer games or whatever, we can provide those for you. Just ask me, you ask Shao. Okay? So there's, as you can imagine, there are infinite things to do in Boulder: hiking, biking, tubing on the Boulder Creek. There's Chautauqua Park, where most of the easy hikes start. Is just half a mile from here down Broadway and Baseline, west on Baseline. There's El Dorado Canyon if you like climbing. Downtown is really wonderful. It's called there's a Pearl Street Mall there, like a walking mall on one of the main streets that runs north, east-west. And also on the weekends, often people go to Rocky Mountain National Park and explore there. You can rent vans and organize groups. People have done that in the past, so I really strongly encourage you to take advantage of it. Okay, so let's see. I don't know if did I cover everything? So Xiao, where's Ke?
I think he's in the office, maybe.
Okay, yeah. So you'll meet the other student, Ke. He's also really friendly, and if Xiao's not here, you can interact with him and ask him for anything you need help with. Okay, so with that, without further ado, I'm going to have Victor come up and say a few words about the program, give you an overview. And just this week, as you can see on the schedule, we have a pretty busy schedule. So tomorrow, so this afternoon we're going to have student introductions, just so we go around the room and just have everybody say a couple of minutes, say where they come from or what they're interested in. Then tomorrow we'll have a public lecture by Professor Giamarchi. And Wednesday we'll have this wonderful cookout that we always have on Flagstaff Mountain. We'll have buses leaving Kittredge at 5:30 and taking us up one of the sort of closest mountains, Flagstaff Mountain. There'll be like a little amphitheater area there, picnic area. We'll have a nice dinner out there rather than in the dorms. Okay, so without further ado, here's Victor. And again, welcome, and it's a real pleasure to see you all here.
Okay, let me start by also welcoming you to Boulder. So I'm one of the scientific organizers, so I have two more, as Lee already told you, but one of them arrives today in the afternoon and the other one will arrive on Wednesday. And then actually for a week and a half I will be away from Boulder, so they'll take over and then I'll come back. So taking turns organizing the school, although I think there's not that much to organize. The school is already set up, and thanks to Leo's efforts, I think everything is everything will run smoothly. So let me tell you a little bit about what kind of scientific topics we'll cover and what is the overall scope of the school. So you can find everything in the detailed schedule, which is in this printout. However, I would like to tell you that, and I've been looking through it, and there were some last-minute changes in the schedule, which didn't make it into the printed version of the schedule. But if you go online, what you have online is up to date. and we further edit it, if there's any last minute changes. So for example, we actually had one cancellation and we have to do one replacement, which I'll tell you about. But so first, let me mention a few things. So one of them, the kind of topics which we'll cover during the school, which might be the most important thing. So we would like to start this week with covering the most basic aspects of disorder. After all, the school is on disorder, and you can't study disorder without studying Anderson localization. So we'll have Anton Andreev talking about Anderson localization and metals. We'll also, if you talk about disorder, you cannot talk about Cohen Hall effect. So we have John Choker talking about this. And there are some very interesting aspects of disorder, of Anderson localization, and more complicated problems of disorder in one dimension, which Thierry Gianmarchi is going to cover. And of course, he's the author of a book on one-dimensional physics. So he's the guy to have if you want to talk about one-dimensional physics. At the end of this week, we will start moving on into subjects which, broadly require interactions to understand, although I think what Thierry will talk about also require interactions. But Anderson localization itself is a phenomenon where you don't need to have any interactions. It's a single particle problem in the disordered potential. So we would like to move a little bit further towards what is understood about presence of interaction and disorder. And we'll first have Misha Reich talking about Hawking transport, which is not quite yet interactions, but it needs to involve some interactions at least. And then we'll have Leonid Glazman talking about weak interaction effects and things like Altshuler-Aronov corrections to diffusive behavior in metals. And at the same time, we will also have Dominique Delance talking about a rather interesting aspect of disorder problems. So there is a particular direction where people try to move, where instead of studying disorder, they study chaos. And so chaos has some similarities with disorder. But what's interesting that recently, by realizing a chaotic kick-thrower problem experimentally, people were able to observe Anderson localization experiment and actually even study its critical properties. And so he'll tell us a little bit about these developments. In some sense, it's a side development compared to other things we'll be covering, but I think it's an important subject which we can't just omit, and it's great that we'll hear about it. Then subsequently, we'll talk a little bit about disorder and phase transitions. There will be lectures by Thomas Wojta, and Gil Raphael will talk about real space normalization group, a certain approach developed first by, I think it was Gupta Ma, but actually really developed by Daniel Fisher later, which allows to study certain one-dimensional, strongly interacting and disorder problems. And so then, as we go to week 3, we'll have a few more lectures going even further into problems where you have to have interactions. First of all, we'll have Daniel Hughes talking about a certain type of problems which I would say maybe now on the frontier of current understanding of disorders. So he'll talk about many-body localization and thermalization in certain systems. So maybe you know that many-body localization is a concept proposed by Basco, Altshuler, and Aligner back in 2005, and it still remains, in some sense, not very well understood. So I think that there's a general agreement that something of that sort happens, not really, people don't really understand exactly when it happens and what are the properties of this. And this is one of the things where I think you can just start working on it right away, because there are so many questions which are not yet answered. And David Hughes thought about these questions quite a bit, and so I think he'll tell us about them. We'll also have Alex Kamenev talking about Keldysh approach to disorder, using Keldysh diagrammatic techniques and Keldysh sigma model. It's one of the approaches which allows to include interactions from the onset in the description of disorder problems. And so we also have Alex Altman, and actually the subject of his talk has been changed because he's Altman, and he decided that he wants to talk about Altman's and Bauer symmetry classes. It's a particular classification of disordered problems, which originally only applied to problems of Anderson transition type. But these days, this became very important for classification of topological insulators, because those are understood as, or could be understood as systems which are insensitive to disorder at their boundary. And so instead of talking about semi-classical approach or split theory approach to semi-classical problems, he will actually talk about Altman's and Bauer symmetry classes and the application of different problems. with disorder. And so let's see, so that would be the week 3. At the end of the week, we'll also have Stanford Kurm, who is going to talk about some experiments on dynamics in ultra-cold gases. And finally, the week 4, I guess the highlight of the week would be Mirlin, Alexander Mirlin, who will talk about application of the concept of disorder symmetry classes to problems ranging from graphene to topological insulators. He may tell us about sigma models and classification of topological terms in studying disorder problem and these kind of topics. We'll also have Anatoly Polkovnikov talking about semi-classical dynamics. We'll have Karina Kolov talking about approach to study dynamics in ultra-cold gases. So we were supposed to have Ali Yazdani talking about some experiments on disorder systems. So unfortunately, he cannot make it here. So instead, we'll have Eric Carnell talking about dynamics in certain quantum gases. So you may know Eric Carnell is from here. Has a Nobel Prize for making the first Bose-Einstein condensate, so it'll be interesting to hear what he'll have to say. So this is basically all. This is all 4 weeks of our program. So one thing I would like to add is that we would like to have poster sessions, and I think all of you were asked to prepare a poster. There's one problem with poster session, or maybe even 2 problems, that we didn't quite figure out how to organize them yet. So normally, for example, in week 2 and 3, according to our current schedule, we'll have poster talks on Tuesday, where everybody will give a short talk describing their poster, everybody who will be presenting a poster that week, and then we'll have a poster session on Wednesday, actually presenting the poster, and I think we're going to split you in groups and ask you to present these posters in groups, and perhaps this will be 4 groups. Now, the issue with the schedule is that this week we have a lot of stuff happening. So for example, on Tuesday we have TRS public lecture, and then we have cookout at Flagstaff Mountain on Wednesday. So we cannot have poster talks. So far we only scheduled a poster session on Thursday, and we will have to discuss this today and figure out what to do with poster talks. And so we'll make an announcement about this, and we'll also tell you how this will be organized later. But so I think there's also a typo in week 4 where poster session, and then this is the type in the printed out version. So the Tuesday poster session is poster talks. I'll label this poster talks 3 instead of 4, and then on Wednesday the poster session is missing, but this will be corrected if it's still online. Maybe it's already been corrected online actually. Okay, so let me see. We also have 1 or 2 slots for a seminar. And we don't yet know what that seminar is going to be. Maybe one of you will give a talk, but we'll make an announcement about this later. Okay, so with this said, it's now 3 minutes to 9 o'clock. So maybe that's essentially all I wanted to say for now. We'll make announcements as they come up. As relevant stuff will become available for us to talk about. But in the meanwhile, our first lecture is going to be by Anton Andreev, and I just saw him walking into the room, so I'm hoping he's around. And so he will give the board. So maybe on the right.
You using Blackboard then?
Can you hear me okay? From the back?
There is a microphone there. So simply use your controller volume. Oh, so it should be all this.
Or you took all the ones that
No.
are
Oh, I think it should be here, but maybe it's not. Because that's with the envelope. So it's
My name is Anton Andreev. I want to first of all thank the organizers for inviting me to this wonderful school. It's an honor to be here. I was asked to give an introductory class on theory of transport in resort systems. And what I would like to do is to give a pedagogical introduction on the diagram technique for resort systems and on the signal model. And I will attempt to explain the physics behind the formalism. I think it's very useful to do in general. And also in diagram technique, we're fortunate in that people who developed it also developed a very intuitive language for describing the phenomena described by diagrams. And I will try to introduce this language and use it. So Anatoly Larkin used to say that sciences can be classified into oral sciences and written sciences. Written sciences are those which can be easily formalized and nicely put in the form of a textbook. And the calculus is a good example of a written science. And also oral sciences, which are those which cannot be easily formalized, but they're easier to pass on in the one-on-one interactions. Geometry in ancient Greece is a good example of an oral science. It was taught in small schools in person with drawing pictures in the sand with a stick. But because of that, this tradition is largely lost because it's hard to put in written form. So in this sense, diagram technique is an oral science, and I will try to present some of this oral lore that was developed. Okay, and so now I will start. In theory,